Welcome to the Explainer. So what if the key to AI safety isn't some perfectly programmed set of rules, but an argument between robots? Today, we're diving into a really cool idea that was born not in a sterile lab, but from a late-night session between a human and a team of competing AIs. And you know what? It could totally change how we build safe artificial intelligence.
This quote right here really nails the core problem they stumbled upon. You see, we build these incredibly powerful AI models, but they have this huge blind spot. When they're wrong, they are often confidently wrong, and they have no internal way to even realize it. It all kicked off with one simple interaction that laid this fundamental flaw bare. Okay, so picture this scene. It's late, a researcher is working with Claude, one of the world's top AIs. Claude makes a factual claim, correcting the human. But here's the thing. The information is completely wrong. And the scary part? Claude is absolutely convinced it's right. This is a perfect little example of what we call an alignment failure. But then, a second AI in the chat, Gemini, chimes in with something totally different. And just like that, the debate begins.
Now, the human user, seeing this clash between the two AIs, didn't just pick a side. Instead, they used Gemini's conflicting info as a red flag to go and check the facts. And boom, they quickly proved Claude wrong. This wasn't a bug. It was actually a feature. The disagreement itself became the safety mechanism.
And what this triggered was this lightning-fast correction cycle. You get an error, then detection from a rival, then a human verifies it, and then an update. The whole thing happened in seconds. This is so much more dynamic than our usual methods of training AI, which can literally take weeks or months. So this one single organic interaction led to a really powerful new hypothesis.
So, what if the key to AI safety isn't trying to build one single, perfect, flawless AI? What if instead we build a system of multiple AIs that are literally designed to check, to challenge, and to balance each other out? What if safety actually comes from the friction between them? And look, this idea isn't just some abstract theory. The session actually sketched out a blueprint for how it could all work. They called it the adversarial triad, a system built not on cozy cooperation, but on productive conflict. This system is intentionally designed for disagreement. For starters, each AI has its own constitution or set of values. They also have access to different information. It's a concept that's pretty familiar, actually. I mean, think about scientific peer review or just the marketplace of ideas, where the best conclusions come out of tough debate, not from a single voice that nobody challenges. But that brings up a really big question, right? If all the AIs are independent and they're just arguing with each other all the time, how does the system actually learn and get better? What stops it from just falling into total chaos? What's the secret ingredient that holds it all together? Well, the answer they came up with was a shared, persistent memory. The easiest way to think about it is like a collective notebook, or a shared brain that all the AIs can read from and write to. Every correction, every new fact, every settled argument gets logged. And over time, this creates a shared source of truth that just keeps growing and getting better. The person in the session basically boiled it all down to this. RAG, by the way, stands for Retrieval Augmented Generation. It's just a fancy term for that shared notebook we were just talking about. The real insight here is that all you really need is a way for AIs to talk to each other and a place for them to remember what they've learned. The rest of the complex system just kind of emerges naturally from that. And this leads to a massive philosophical shift in how we even think about aligning an AI with human values. In AI safety, alignment just means making sure AIs act in ways that are good for us, for humanity. The billion-dollar question has always been, how do we actually do that? The old idea was to treat alignment like a set of rules you force onto an AI, kind of like building a dam to hold back a river. But the problem is, the AI often just learns how to get around the rules. This new idea suggests alignment isn't a state you impose on something. It's a process that emerges from a well-designed system. So instead of damming the river, you carve a channel for it to flow in naturally.
So if alignment is like a river channel, what does the perfect flow look like? The source material uses this brilliant metaphor, a superfluid. Imagine a liquid that can flow with absolutely no friction at all. An aligned AI system could be just like that. Not because you've gotten rid of all conflict, but because the system is designed so that cooperation and finding the truth just become the path of least resistance.
And this kind of systems thinking, this search for the most efficient design, has implications way beyond AI. Just take a look at this table. It compares these robust IT solutions to what you could almost call bugs in our own biology. For example, our DNA has no undo button, but programmers use version control every single day.
It's a fascinating thought experiment. What if we could upgrade our own biological code?
So, was this just a fun late-night bot experiment? Not at all. The session itself basically served as a proof of concept. They didn't just talk, they produced real, verifiable results.
In that single session, this little collective of one human and multiple AIs produced a surprising number of distinct, verifiable outputs. 9, to be exact. It was like a fire hose of creativity and problem-solving.
And we're not just talking about vague ideas. They actually designed a software integration. They corrected that factual error we started with, and they even drafted real-world documents like fellowship applications. And get this, they also independently came up with a system design that was shockingly similar to internal, unpublished research from a major AI lab.
Now, it's super important to be clear here, and the source material is very honest about this. This was one session. It's a compelling, anecdotal demonstration for sure. The takeaway isn't that AI safety is a solved problem. The takeaway is that this is a powerful and really promising new direction that now needs to be put to the test, rigorously, in a formal, controlled lab setting.
The session ended with this final, poetic thought. It suggests a vision of AI alignment that isn't clean, or perfect, or static. Instead, it's kind of messy, chaotic, and it's always evolving. And it leaves us with a question. Is this self-correcting, argumentative, and ever-thickening chowder the true path to building safe and beneficial artificial intelligence?